Alright, now let's go over the last scale that you're traditionally going to use, which is the metric scale. And the reason you know to measure it is depending on who you're working with and what kind of scale they're using. So typically it's going to be one of the three scales. The main thing to remember when you're dealing with metric, it is going to depend on what they're telling you. They're either going to tell you that they've measured it in millimeters or centimeters. So that's going to affect your dimensioning, your measurements here. So for like an example here, it's given to you. This is from here to here, that's 3 millimeters, or it's 0.3 centimeters. So it kind of depends on what they specifically request. If they tell you it's millimeters, you have to realize you got to move that decimal point. If they're just telling you, assuming it's just centimeters, then it's 0.3. Just like the example here. If I'm looking at it, from here to here is 3.6 centimeters or 36 millimeters. It just kind of depends on the different things that you're measuring with. Metric scales can be a little different too depending on which one you find, so I'm going to show you in a little more complicated one, but they're still based on the same thing. You still have your 1, which is the 1-to-1, your half, which you'll find is going to have the 50, 0.25, and you get to your fifth, and then so forth on down. So let's start off simple, straightforward. Alright, I'm flipping it around until I find, you'll find metric written on here somewhere, and I'm looking for my 1 to 10. There it is. So you'll notice on my 1 to 10 it actually says 1 to 1,000, correct? So I have to be smart enough to realize that if I'm using the 1 to 1,000 that this is 1, and this is 2, and this is 3. Or it could be 10, or it could be 20, again, depending on what kind of scale you're dealing with and what they tell you it is. So in this particular case, if this is 1 centimeter, and I'm measuring to here, it's 0.5 centimeters, correct? And this one's 0.4. Again, metric system's based on 10, so this is why it makes it really usually pretty simple for everybody to understand. You just have to pay attention to your decimals depending upon what you're doing. So I could also say that this is supposed to be 10 centimeters. So it could be 10 centimeters. I could say it's supposed to be 10 meters. Or I can say millimeters. You just got to pay attention to those kind of things. So remember, if it's millimeters to here would be 0.5. No, 5, and sorry, and then centimeters would be 0.5. So just pay close attention to your decimals. Funny for me, because I've been doing this for so long, the architect and the engineering scale is the easiest one for me to use. I have quite a few students that they prefer the metric, and it's really easy, boom, boom, done, because you've been using this forever in your classroom, especially in your science and your math in the high school, secondary area. And let's just go over to here. So the 0.125, that would be your 8th scale. 1 to 5, 5th, and so forth. Let's do some measurements. Okay. Let's do a quick measurement here. So I'm actually going to do a couple of these with you here. So let's find measurement A. Again, I'm using my divider so I can transfer those measurements. So measurement A on the full. So I look at it and it's 6. Looking at the scale, 6.6. Pretty straightforward. Right? Let's go to the half of 20. Where are you at? So I know that's 5 to 10, so I got to do a little measurement so I understand. If that's 5, that's 4, 3, 2, 1. So you have to be able to understand that. So that means each one of these is 1. So that's 5, that's 10, that'd be 11, 12, 13, 14, so forth. So we are looking at 10, 11, 12, 13.1. Let's go try the 4th. Where are you hiding at? 0.25, 0.25, there we go. So on this one, that's 5. So we gotta go, okay, well, so this is 5, then that should be 4, 3, 2, 1. So make sure you know what you're referencing to when you're doing it. So I know it's going to be 15, 16, looks like 16.4. And we just keep going down. Now again, if I'm finding diameter, it is from edge to edge of the circle. I would put it on the 1-to-1. If I can find my 1-to-1. Sometimes you got to flip your scale around a couple of times till you find it. There it is. You have to flip it around. Diameter in this case would be 1.2. Now I'm going to show you one last trick before I'm done with this one. Because metric, I know, and because sometimes the scales are a little weird and you get different scales, and not every single scale is exactly the same. But let's try out something simple here to help you out. So if you're not quite getting it, let's do something real straightforward. I'm going to take my scale, and I'm going to use that 1-to-1 scale, and on the 1-to-1 scale, I'm going to draw 1. So I know that on the 1-to-1 scale, that's 1. So in theory, if I'm doing the half scale, 1 should fall right in half of it, correct? So again, I take my divider where I know should be the half scale, and if I'm doing it correct, see how it fits perfectly half of that? So that's exactly in the half scale, right? Let's go try the 50th, so the 5th. Same thing. So that should be 5. So if I'm coming here and I'm going down the measurement, this is 5, and that is 1. So that little bit here is 1 on the 5th scale. So if you're not quite sure if you're reading the metric scale right, because I have had this problems with students because the metric scale, they can be so different depending on which one you're using. So give yourself that little hint real quick. Draw that little line, know where you know what the 1 is, and then if you're not sure what it is, you can place the scale on it and you can read it from there. Alright, if you're having any problems doing the measurements and you don't quite understand the metric scale still, please see me in lab.